So welcome to the session. We will start with the module one. As I mentioned earlier, the module one, we will go through about the fundamentals, what is all required to be getting started with Elastic and whatnot. That would be the part of session one. In today's agenda, we will understand about like what's the definition for Elasticsearch, at least a informal definition, and the benefits you get out of Elasticsearch or ELK Stack and various jargons or terminologies, what people tend to use it. And finally, we will wrap up the session by understanding the key architecture of the ELK Stack completely, how is all being built and what's the nuances behind the scene, and we'll also see the components overview one by one. That's the whole part here. Now, before we start with any technology, right, we have to ask all the three fundamental questions, or I would say three whys. What, why, and when. Basically, we want to understand like what is Elastic and why we should use it and when should we use it. Once every time a technologist understand or a developer or a DevOps who understand all these three why, right? It's always easy to go and apply at any point of time, every session, every new use cases or new technology you learn, right? It's easy to understand and compare and if you ask me whether this is a standard definition of Elasticsearch, it's completely no. There is also other definitions you will find there. But for any software product, right, you'll not be able to give a concrete definition. Hey, this is what the definition. If anybody can give a definition like what is Microsoft 17 or 11 or any operating system, right? It's very hard to give that quantifiable definition. They would say that it's a wrapper between the hardware to your software. That's all they'll be able to do it. But any software system out there, people will be able to give a definition only based on its characteristics, what it actually behaves. Now let's think about five attributes being mentioned here. Let's understand one by one. So it's been mentioned that it's a real time. So what would be the opposite of a real time, Will? And like, can you just let me know? Let's keep it more conversational. So what do you think would be opposite of a real time? Hello.
Yeah, okay.
Yeah.
Opposite of
So
real time.
what would be the opposite of a real time? So So there is
So,
something called real-time computing is there. So any thoughts or guesses like what would be the opposite of a real-time computing?
A time that is lagging behind, that is not the actual moment. Let's say
Okay.
15, 20 minutes pass or seconds past.
Mm-hmm. Okay. What would be the opposite of the same in computer? Any thoughts?
At that instance, you that particular time.
Mm-hmm. Okay. So if you think from a vocabulary point of view, right, there's the opposite of real time. We call something called batch computing. So, for example, you might have seen multiple jobs in your company where, like, take an example of API, right? If you request something, most of the time you'll get the response very quickly. But there is also other cases where you might be running a lot of cron jobs every day, like any sort of a maintenance activity or any sort of a backup activity. Those don't run in real time. Instead, they run at a quantifiable time that, hey, I'll run every 24 hours or every 1 week, depending upon the sensitivity of the data, right? So that is a key difference between a real time and a batch system. So majority of the bank transaction, heavier transaction, usually they do a batch type. Batch can be of any frequency. They usually run every 1 hour or every 2 hour, depending upon the batch size, etc. So there is always a difference between a real time and a distributed computing altogether. Now, coming to the next part to something called distributed search. Now, this is where it's actually getting much more interesting. When I say distributed search, right, it says that my request is being sent to multiple people who are working in parallel to accomplish or solve the job for me. That is the whole definition of the distributed in nature. When distributor comes in picture, so the next first obvious thing we need to have is, hey, how can I have multiple machines to do my job? So think about like the classical school example, right? Think about like in case if you are going for a college or a university, and the faculty need to evaluate all the sheet which has been manually been filled by the students. Let's assume that you're writing some essay, and that essay has to be graded by the faculty. Now, assuming that the class strength is of 30 people and there's one faculty, even if we keeping like 2 minutes per essay, it's going to take like 60 minutes for a professor to complete all the evaluation. Instead, if you think about like having another a teaching assistant or another assistant for the professor, now the evaluation time all the way decreases from 60 minutes to 30 minutes, assuming there is one more people. So as we add more people into the system, we are able to process more data. Do you guys agree with me? Generally, like if you add more people to any sort of a task, it increases to some extent. Do you agree?
Right. Mhm.
That's true.
Yeah. So that is the same logic is also being used in Elastic. If you add more computers or computing devices to Elasticsearch server, right, then your performance is also increasing quite a lot. So that is the true part. So Elasticsearch can offer you real-time data. If you ask something, it can give you almost real-time data with just like a few seconds delay. Distributed search is what is being accomplished because that if you need to ask a lot of questions, right? Only if there's multiple computing device, you'll be able to distribute and get the data. So by default, Elasticsearch is distributed in nature. And the last definition, we have something called analytics on large data. So majority of the time, or let's even think about the first principle thinking, right? We all store data like taking from logs, computers, and all different machines, right? The key purpose is all to do some sort of analysis, whether my SLAs or my issues within the all the computer uptime, downtime, response time is all within the certain standard. So what we are end of the day doing, we are trying to do some sort of analytics computation on the data whether all my computers are behaving right, depending upon the KPIs, it actually does. It can be a response time, it can be a latency, it can be the storage size. A lot of different parameters can be managed accordingly. All these things are managed effectively in Elastic. And coming to the next point, regarding the scalability. So by design, right, usually all scalable systems are designed to do in two types of ways. One is something called horizontal, the other is something called vertical. It's very easy to understand like what is meant by horizontal and vertical here. When you think about the horizontal scalability, right, you have multiple workers to accomplish a given job. Let's assume that you are constructing a house, and if you depute more people, then the construction time would obviously improve a lot. That is the example because you are trying to distribute your work across multiple people. On the other hand, the vertical scalability. Just to give you analogy, there can be a very seasoned, experienced person who knows to solve very critical problem very easily. So that guy can be an example of vertical scalability from a real world. Just translating exactly to the computer space, vertical scalability here, think about your laptop, right? If your laptop is not performing very good, so next thing you always consider, hey, can I increase my laptop specification? Either can I increase my storage, or I can increase my RAM, or I can think about adding extra GPUs to it, external GPUs to it. All these are like vertical scalability. So basically, you are trying to increase a resource for a given machine only at the machine level or node level to accomplish certain thing. That is the exact thing for a vertical. But the problem with vertical scalability, it is so limited because think of your laptop, right? You will not be able to add more amount of RAM after a certain size because there is a hardware limitation. Your laptop hardware maximum can accept like 16 GB or 32 GB depending upon your specification. So there is always a limitation to vertical scalability. Even if you think about like a servers within your computer, I mean, within your premises, right? That can be like a big server having 42 cores, etc. Even in that machine, exceeding a certain amount of a RAM or a storage becomes very tricky because your hardware is not designed to scale after a certain point of time. So thinking about all these scenarios in mind, we have to have a other strategy, which is the horizontal. The idea is hey, if I need more computation, I'll keep adding more amount of node, so that you are not trying constrained by the hardware device. You are just if you just have more devices at your disposal, and if it's all available connected to each other, right, then you will be able to accomplish the horizontal scalability without any problem. So that is the beauty here. Okay, any questions before I go into the next thing? Any question, guys? All right. So next part is that the ELK stands for Elastic and Kibana. It actually covers very well on Logstash and Kibana. So there's an entire full stack observability is being accomplished on top of it. And the very thing is all the Elasticsearch is built on a library, something called Apache Lucene. It's good to know. Apache Lucene is the heart of Elasticsearch. It's an open source project and it's been developed in Java. So that is the only difference, but we will see more about Lucene later once we go into it. And the last but not the least, the different use cases people use it is on logging, monitoring, security, and a search application. All these different use cases, Elasticsearch can be a first-class citizen in all of these. Now coming to decide like when to use it. So if you want to do any sort of a search or analyze operation in real time, that's a good candidate. Log aggregation, it's a really excellent candidate. Building a search feature, again, a really use case. Whenever if you wanted to analyze a huge amount of data in real time, also to search the data, right? When I say mentioning about a search, I'm not speaking about the ID search or something. I'm referring to a complete search on your data. For example, if you have your insurance card, right, or insurance policy detail. If you want to search a particular term, what we usually do, we just open the PDF and do a control F and try to locate where exactly that word has been associated. Instead, if I'm able to contextually search the information very similar to how people tend to search in Google search, right? Hey, what is the insurance policy is actually saying to me, or more of think like a chat GPT kind of a system, right? If you want a system of these kind, then Elasticsearch is a really good candidate to accomplish it. And what are the different companies out there using Elastic? Almost all different companies you see on the picture is all using Elasticsearch, starting from Uber, Wikipedia, Spotify, and Bitbucket, Datadog, all these bigger giant, right? They inherently use Elasticsearch behind the picture to solve certain of their problem. Even let's take an example of a Netflix. Netflix is also still using Elasticsearch. Can you just think like where exactly Netflix is using Elasticsearch? Any guesses or thoughts?
Can you repeat that question?
So my question is where exactly Netflix is using Elasticsearch?
When you're searching for a movie,
Precisely. Let's go for other example. Where exactly do you think Wikipedia is using Elasticsearch?
when you're searching for documents or any related text.
Perfect, lovely. So now you get to understand, right? More than log aggregation, etc. If we have a proper search problem, then Elasticsearch is the engine behind the scene. For example, if you wanted to watch a movie or a series, right? You don't try to go and type the full name of the series name or the movie name. One example would be the Harry Potter. Harry Potter being the prefix, and every movie being released has a kind of a certain suffix to it. Prisoner of Azkaban, Goblet of Fire. You have multiple things, but you don't expect to go and type in your TV or anywhere. You always type Harry Potter, and you expect Netflix to start storing up those movies onto it. So all these kind of a search operation is what being powered. Likewise, searching for a Uber, right? Uber, when we wanted to search for the nearest taxis, etc., where is all they are located, Uber is actually been powering being a scene. Now, let's think about the fundamental difference. What is meant by SQL databases, which has been ruling market and still is going to rule the market. But the caveat here is SQL is being designed to do something else, and Elasticsearch is designed to do something else. We will understand one by one. So the first and foremost, right? We all know that SQL databases, when I refer, it could be like MySQL, IBM DB2, Microsoft SQL Server, and Postgres. All these different databases out there are strictly SQL databases. And you think about Elastic, all the features we all spoke about is all being designed. Now we all know SQL servers are being designed to handle rows and columns. So if you have rows and columns kind of a data within you, then SQL Server will work like a charm. On the other hand, if you think about having like Elastic, right, it is designed to handle some sort of a free text. Very example, you mentioned that the searching for the movie, right? When you want to search a movie, how it all works, then look for any certain thing. Movie can be of a very unstructured data. Yeah, I'm having a title, I have a description, I have a genre, what genre, like whether it's a thriller or comedy. I have like multiple definitions to the movie. Now, as an Elasticsearch engine, I have ability to search across all different data points. I'll show you one real world use case how Amazon is actually using it, which we have been using it for a quite lot. I'm just going to amazon.com, and if I want to search for a laptop, let's say I'm going to search for HP laptop. When I hit HP laptop, if you notice here, I just do my query on a free text search. Once I start to give a free text search, wherever the word HP and laptop is being incorporated, if you see, it's all been highlighted very well. I never say that this is the brand I need to select. I just said the information is able to infer it directly by able to infer that, hey, this guy is asking about a laptop and is looking for the specific thing. But if you notice from page number 2, I'm started to also getting a different companies like Omnitia, like other laptop which is not a brand of it. So the powerful part of the HP laptop in a free text search is actually searches the product title, description. When I mention a product title, etc., right? Once you open it, you have your detailed description about what is the item is all about, and you have all the specification like a brand, model name, hard disk, etc. Like so, it goes in detail, and you have a product information and additional information. All these comes in detail. So Elasticsearch is designed to search across all these data points and helps you to give you the data in some sort of rank fashion. Now you understand like where Elasticsearch actually powers very well and where databases like SQL is not designed to handle these kind of a data doesn't shine out because SQL databases will expect every other laptop specification to be in a structured format. But we all know that certain laptops might not have a certain hardware at all. So storing unwanted detail, etc., is gonna cost you the null constraint or a default constraint, which is gonna make your size of the database to be very huge. So those are the key problems we generally tend to have it in SQL. And before we start any with the SQL database, the first and foremost step would be like define the schema. Hey, what is the exact schema I need to provide to it? Like creating table or creating databases, I need to provide beforehand before I accomplish something. On the other hand, Elasticsearch, it doesn't mandate you to provide it, but later in the class we will see like why it is kind of required from a business point of view. And the other aspects would be the search, real time, etc. So when you think about the search type, right, the exact match is what usually the SQL databases does. If you want to do anything complicated, still you can able to accomplish using SQL. But have you guys know about the like operator in SQL? By any chance, like have you worked on any database systems? Have you heard about the like operator?
No.
Okay, like operator in the sorry, in the SQL databases will allows you to search based on the how do I call it certain pattern match. I'll show you an example how it all works from a like perspective. I'll quickly show you. So like operators actually helps you to do some sort of a pattern match. Hey, I like to search for a word starting with Harry and Potter, etc. These kind of examples you will be able to see. For example, if you have a lot of data here, right? Here they have a city here. Let's say they have Berlin, Mexico, and London. Instead of I have to give the exact name, instead I can go and type, hey, if any city starting with L, give me all the city name. So it'll be able to give you me saying that, hey, London or Yulo is all the thing. So if you notice here, O is missing, DON. So if I try it out, right, if I run the SQL query, so all the databases which contains London is all been written because I have given my pattern match. But if you go and speak with any sort of DB admin, right, they will say that, hey, don't try to use like operator very heavily because SQL's database is not designed to handle it. So system will have a lot of repercussions when you try out those things. So that's the usual verdict people tend to do it. So so these are the problems what Elasticsearch tend to overcome. Your search, etc., is much easier and getting to such data will be much faster. Now, we all saw that like what and when. And let's try to understand like why Elasticsearch is like super powerful compared to other databases there in the market. The first and foremost thing, it uses the algorithm, something called inverted index. It's not required to go in detail, but just from a theoretical point of view, try to understand like what is the algorithm is being designed to handle it. It's using inverted index, which makes the system more powerful when it wants to return the data back from the Elastic. And the other benefits we all know it's highly scalable, easy to deploy, distributed in search, whatever the attributes we saw for Elasticsearch, every other benefit will go inside the same. Now, coming to the terminologies. Here, the terminology here, if you want to think about like what are the different terminologies we have to see, there is five key things: cluster, node, and shard. Cluster is a group of computer which tries to work as in a single unit to solve a given problem. It's a logical entity. Think about having a cluster in your office environment, right? You might have multiple clusters, and these clusters will be joined with a common name and will be trying to solve a given problem. So the cluster will be more of a logical entity which holds your entire data, and that will be the single point. And node is a single server. For example, your laptop also can be becoming Elasticsearch node, a laptop or a desktop. If you have multiple machine, all these machines will be a node of the will be individual node. Or in a simple definition, if you are running Elasticsearch instance in your laptop, if you download and install, that becomes Elasticsearch node by default. As simple as that. Now coming to the shard. So before you have your shard, right? Shard is one of the basic entity of an Elasticsearch. It's a fundamental unit. So multiple shard will make up a given index. So when I say index, right, I'll just go to the next picture here. So this is an example here. You have the clusters on your left where it composites of three different nodes. You have node 1, node 2, and node 3. And after which you have your shard in this equation. Shard is actually nothing but it has like think about like a shard for a given movie database. I might have all the movies released in 2010. Let's say there's 1,000 movies being published last year. Then all these 1,000 movies will be holded in a given index. So the index name, let's call it something called index one, and the total storage size is like 500 GB. Now each of the index is broken down to a small piece or file. That file is something called a shard. So this shard is what the fundamental entity, what Elasticsearch is powering behind the scene. And the again, the shard is also having two kind of a different attribute. We call something called primary shard, and we also have something called replica shard. Primary shard is nothing but the original copy of the data. Replica shard or the secondary shard is a copy of the data here. So usually people tend to achieve the scalability in two different ways. either by adding multiple nodes, which can do the computation, or having multiple.
Sorry, I have a question.
Yeah, go ahead.
Sorry, can you explain the chart again one more time?
Yeah, sure. So you understand what is cluster and node, right? Any question till this point before we go into the chart once again? Are we clear
Uh,
with the?
yeah, I'm
Sorry,
clear with the cluster and the node.
come again.
I'm clear with the cluster and the node.
Okay, awesome. So think about a index is like a database or a simple table. So you understand SQL table, right? What is a table is all meant about, right?
Yes.
Okay. So just going back to SQL example, a table will have like few records to few thousand of record. For example, if you want to handle the employee information, then you people tend to have something called employee information as a table name, and they will have the employee ID, name, age, address, and what department they belong to. All these information will be stored in the employee database or employee table. Now, just translate the same back into Elastic. Here, the table equivalent is what called as index. Exact translation. But a index is further broken down into something logical entity called a shard. Why index is broken into a small amount of shard is the following reason. You from the first session we spoke first a few slides before we spoke about, right? Hey, we want to store the data distributed in nature. When I say distributed nature, only if I divide my data into small components or a chunk, I can distribute my data. Do you guys agree with me? I'll repeat once again. Only if you store the data in small components, you will be able to distribute the work across multiple people. Think about running a large project, right? If you have a bigger project and you don't expect one team to solve or one person to solve, instead, the whole project is broken down into multiple milestones, and each of the multiple milestone is broken down into a small module so that each person will be responsible for module. There will be a person A will be responsible for module A, module B, and module C. They also can be part of the team. So your whole data is broken down into smaller your processable chunk. That small processable chunk is what is called a shard. And these shards don't sit onto a same computer. Even though if you call like, hey, I have a three node machine, assuming that we have three machines, you, me, and I, like we have three machines, and if I have a record size of 1,000, right? The first machine will have 300. Second machine I will also have 300. Fourth machine have around like 300 to 400. That is how equally the data will be created. The broken down data is what called a shard. Is it clear now?
Very clear.
Perfect.
Thank you.
Awesome. So now coming to the shard, right? Again, shard is broken down into two flavors. One is something called primary and the replica. Primary is nothing but the original copy. When I store something, that data becomes the primary. At any point of time, my data also can be copied out separately. That is what people call something called secondary shard. So why it is so important? Let's take an simple example, right? For example, in a university or a yeah, let's take an example of a simple university. In that, there is a professor has given that mark sheet of what are the grades the students have obtained. There is only one teaching assistant is having the data. Now, what will happen is that professor says that go and check your mark with the teaching assistant. He has all the information. Everybody out of curiosity, they go to teaching assistant, they'll try to say, hey, what is my grade or mark, what I've obtained for this assignment or my exam. So a teaching assistant being the person, he'll be able to answer one or two questions per second. Hey, this is your name and this is your grade and this is your name. He'll be able to answer it. But if entire class of all 30 or 60 comes to the teaching assistant and start asking questions, right? What he'll say, hey, please come in queue, I'll answer one by one. Instead, the same professor, if you have duplicate the data into two copy, hey, first you have a copy and you another person will have another copy. If they have two persons being copy being created, Instead of waiting for the person to complete in n amount of time, so the whole computation will be done by n by 2. Here is the number of seconds or minutes it takes for people or a teaching assistant to share all the marks with the fellow student. Now you understand, right, what is meant by primary and replica. So this is also one other way people tend to accomplish a distributed nature, like how they want to solve the problem. Clear? And I'll quickly jump to the yeah. So this is a quick summary here. Cluster is a group of nodes. Their job is to distribute and coordinate the work. And node is a single server or a laptop or a desktop that becomes a node altogether. And the shard is subdivision of an index, as I mentioned earlier. If you have an index of employee, it's broken down into a smaller pieces. And
Right.
then it's broken down into other components like primary and replica, depending upon the how it's having the original copy or a backup data. Any questions?
Yeah. How many nodes can you have on the cluster?
So there is not a restriction saying that you can have only certain number of node, but there is a design pattern. They always say that you should have like a odd number of node. You can have node number 1, 3, 5, 7, etc. And any reason why people are saying that odd number of node is better compared to even number of node? Any thoughts or guesses?
I have no idea.
Yeah. So think about this election point, right? For example, in a country, if there is like only 100 people are there. So
Yeah.
if both of the people go and vote for one candidate, another person like votes 50, right? If there is 50-50, right, we will not be able to come for a conclusion who is the winner or who actually won the election. So the same logic applies for the cluster because cluster works in a group. Somebody has to take the decision. Hey, I should be the master. Everybody should work for the job what I depute to me. That's a classical way how it all works. People call us a master node or people call us the master and slave, depending upon the architecture, right?
Yeah.
So in order to have a group of nodes, right, there will be always odd number of the odd number. Only then if somebody wants to decide who wants to be master, if they want to decide the course of action, it'll be easy. That's the reason. To answer the question, it can be n number of nodes to a cluster, but the only constraint it should be odd number in nature. I even I've seen like 32 nodes or 33 nodes in my experience. Even I scale like till 33 nodes. That's a maximum, and each node is having like 10 cores and 32 GB of memory is what I have seen. Like assume that's almost like a of six almost like 1 TB of memory is what I've managed. Does it answer your question?
Yeah.
Okay. And on the right hand side, if you see here, this is a logical representation. You have a cluster and which contains multiple instance. Instance 1, 2, and 3. Think about your laptop 1, laptop 2, and laptop 3, in which there is something called indices, something called books and authors. Let's assume that there is two different data stores. Within books, data is being stored as a shard, both the primary and replica. Within that, you have the last thing. Hey, this is the ID of the document, this is the section, and this is the content of it. Everything would be showing one by one. All the way from the individual entity, it goes to the shard, it goes to the index, then it comes to the cluster. So now you understand, right, how it has all been associated from the topmost level to the bottommost level. Clear? Okay. Assume it's all clear. And now coming to the architecture. So architecture wise, whatever we have seen on the terminology, right, the jargons, it's all the same. So your system will be having multiple nodes, and each node will be working together to try to solve a single problem. It can be a search operation, it can be analytics operation, or it can be combination of both. And the operations also can be further classified, saying that it could be a read, it could be write, or it could be the update operation. It depends on how it is all being designed. For example, think about a log aggregation system, right? Log aggregation system, think about like Datadog, etc. I'll be interested to search information. Parallelly, there should be also system which will be keep indexing data into my system. So it has to be on both scenario. It has to both search. Also, it has to keep adding more information to it. So the starting from cluster node and your all the systems works in this fashion. This is the key architecture. As I mentioned earlier, Elasticsearch is being designed on top of Apache Lucene. So Lucene is something very complicated. If you have to, today even Lucene is actively being developed. I'm not saying that Lucene is not relevant in these days, but to work with Lucene, right, at least people expect you to have some sort of a PhD degree or a kind of advanced degree on the information travel, because working with Lucene is so complex that it's daunting for everybody, because it's been designed more from a developer perspective. If you have to think about where Lucene is all being used, right? Think about a Mac search or a Windows search. Everybody would have used Windows or Mac, right? In that, if you go to your file system, C drive or any location, if you're searching for any file, right? If you, even if your content is present in some of your text content, it's able to search and provide the information. All this being powered by the Lucene altogether. The problem with Lucene, it's a Java specific, and only a tech savvy person can really make use of it. So what Elasticsearch thought about, hey, this system is like very fantastic, but it's not developer friendly. How can I make the whole system to be making more interesting? That is what people came with a system, something called Elastic, which is a wrapper on top of Apache Lucene, which makes your interaction with system much easier. I'll show you an example in few minutes how it all looks like if you wanted to create a small index in Lucene, because index is not some new concept which Elasticsearch introduced. It's a concept coming from Lucene altogether. How do we create a small document or index, and how does it really looks on creating on Elastic? You will feel that just by the syntax part, it's so simple. They have made the whole experience lot simpler. Any questions before we see an example here?
Good question.
Awesome. Now coming to the example, right? I'll just show you an example from the internet how Lucene search looks like. If I have to go and search Lucene insert a document example, I'm just gonna use the same thing. So you need to write a huge amount of Java code just to accomplish a certain job. Hey, I need to add information about a file, a simple file. It could be having the file field name, file path, and the content of it. That's the exact thing. Now we will exactly see how does it looks like to do it on Elasticsearch ELK uh, index. So I'm just gonna use the same example here. Now, if you notice here, right, I'm just using a simple curl or a simple ELK query. I'm just mentioning, hey, this is what I need to store. And I've mentioned that, hey, this is a doc, etc. So instead of I focus on the business logic, I have to think about all programming construct to accomplish a certain thing. But all the way into Elastic, right? You just focus on business problem. Hey, I want to store the data. That is all I care. I don't care about all the nitty-gritty of it. So my whole operation, all the way from say like 15 lines, right? Let's assume it has 15 lines. My whole logic is composite into maximum of 2 lines. Assuming this is a document to be indexed, I just gonna call it 2 line. All the way now you see, right? Why Lucene was, even though it's quite powerful, it's not easy for people to consume it. On the other hand, Elasticsearch made it super easy so that they said he has dot index, like more of a withdrawal, right? Hey, I want to withdraw money from my ATM. I don't care about how it all interacts with bank server, etc. They like ATM, how it made the whole retrieval process super simple. Now this index method made the indexing operation into Elasticsearch super simple. That's the beauty of it. That's why Elasticsearch got so popular among the people who are using who want to perform some search operation, because a lot of the times these log operations, etc., has to be done by the admins or DevOps, etc. Expecting them to know about all the programming construct is like too much to ask. So when Elasticsearch released, they made the interface so simple that everybody who is like system admin or a architect or anybody for that matter will be able to quickly start their work and go from that point. So that is how the whole Elasticsearch ecosystem has been created for last around like 11 to 12 years. It's been a fantastic boom for Elastic to completely rise up from the bottom and all the way it rise to the top. Cool. Any questions before we saw how do we gonna install Elasticsearch in your computer? Okay. So do you guys have a laptop, which is a personal laptop or official office laptop do you guys have with you?
Both.
Both, okay. Where do you want to install Elasticsearch? Whether do you want to install in local machine or in office machine?
It has to be in local machine.
Okay. So other question would be like, which operating system are you guys using? Whether you're using Windows or a Mac or Linux machine?
Windows.
Okay.
Windows and have
Okay.
WSL installed.
Okay. Awesome. Then in this class, I'll show you the example. How do we install Elasticsearch in the Windows machine? So I'm just going to Google search and typing Elasticsearch download. Once I hit the download option here, right, I will be taking to my official page. In this, it'll ask me to choose a platform. In this case, I'm gonna leave it to Microsoft, and I'm gonna download the version here. I'm gonna hit the download here. It starts downloading. It's gonna take like a few seconds. Parallelly, I'll go to same thing. I'm gonna say something called Kibana download. So always download from the official site. Don't download from any site elsewhere. That is very, very important. And always look for the version what you're downloading. In this example, I'm downloading 9.2.4. That is the exact version I'm trying to download here.
Is that the latest?
Yes, it's the latest one,
Hmm.
pure latest. But in any computer or any of your labs or in your office, right, they'll not be using latest version. They'll be always using one version before that. The
Yeah.
reason is Elasticsearch will be having a lot of updates every month, etc. So keep upgrading to every month is actually a maintenance nightmare and the infrastructure nightmare. So people will be comfortably will be able to live in one version or two version behind the scene, either version 7 or version 8, right?
Yeah.
People will be able to live because like, if you have to keep updating, it's a lot of problems. You might get some stability issue comes in, right? It's going to be always a problem. So when it got downloaded, I'm going to go to the history here. I'm going to open my file system. Let me, it's another screen. So now I'm going to extract the folder here. I'm going to use a 7-zip or you can use a simple zip here. I'm going to say the extract the folder call into the same location. It's extracting now. And in meantime, Kibana will also be downloaded by the time when we have extracted the whole data here. Let's see how much of the data has been left. Few more seconds. It'll be on time. So you'll have a zip version which can be downloaded in your both Windows or any machine. In your office infra, right? Whether are you guys using Windows or are you still using Linux machines in your office servers?
Uh, I use Windows for Office laptop.
Laptop is fine. What about the servers?
Oh, servers. Oh, it depends on the application.
Okay.
So
Assume that you have both Windows as well as Linux
yeah,
machine, Ubuntu, etc. Now I wanted to unzip the Kibana as well. Let me unzip it.
So which one? Okay, I don't want to take us back. So you downloaded the Elasticsearch and Kibana, right?
Yes, I have
Okay.
downloaded Elasticsearch 9.2.4, the latest version. Even it's not a harm that if you go and download 8.x, not a problem. But make sure your both Elasticsearch version and your Kibana version should be identical. It cannot be having a different version, or else it will not communicate with each other effectively. So it should be identical. So
Okay.
once I've downloaded the Elasticsearch, right, I go into the folder and I'm going to open the thing here. I'm just clicking on the download option and I wanted to okay, and open Windows PowerShell over here. You have to click the shift button to open the PowerShell. Once I open the PowerShell or command prompt, whichever works for you, you need to go and type something called bin /elastic. Once you type in, it will say that it's a dot represent the current folder and says that bin Elasticsearch. Once you type in, it start to load Elasticsearch into memory. It might take like few seconds for the first time. Subsequently, the loading time will be much faster. Now you see it started to load. It says that, hey, my machine name is Optimus Prime and what is the location I'm having it. It's all coming up and it's all booting up. It will have WhatsApp memory, etc. I need to do it. As I mentioned earlier, it's all built on Java. You see, right? Apache Lucene Store. As I mentioned, whole of Elasticsearch is being designed on Lucene.
Yeah.
Lucene is what is behind the scene. Now let's wait for modules to fully load up. Once it fully loads up, right, it'll say the Elasticsearch started successfully. That is a message. It indicates that Elasticsearch started in the given server or in a node without any problem. It's gonna take like few seconds. Parallelly, I'm gonna go to the Kibana folder, let it start. And I'm also going inside the Kibana. I'm right clicking on shift button, opening the PowerShell here, and which opens it. And I'm gonna type something called bin/Kibana. The very example what we did for Elastic, I'm just gonna type it for bin/Kibana. Now both of them would be running. It says that module not found. Why is that the case? I think still, oh, still it's loading. My bad. It's going to take some time. Let's wait for Elasticsearch to kick in. So once Elasticsearch has been loaded, right, it will be available in the port something called localhost current 9200. That is a port in which it will be loaded. And for Kibana, it will be loaded on localhost colon 5601. So these are the two ports in which Elasticsearch will be running. I'm going to type it here. Localhost colon 9200. Localhost 5601. So this is for Kibana and this is for Elastic. And the reason we are running it on localhost because I'm running from a local machine and it's installed in my local machine. So I'm using localhost. If you want to access it from remote machine, instead of localhost, you need to type the machine address directly. It could be like saying that 192.168.1.1. If you type it and type it along with the port number, assuming that you have enabled remote access, and firewall policy is discarded for this port, then you'll be able to access the Elasticsearch without any problem. Likewise, same thing for Kibana as well. If you just wanted to start it in a machine, and if you wanted to use a server, people can use a server over here. Yeah, now it's all loading up, almost like a majority of the modules are being loaded. It says that okay, discovery, it says initializing, starting, fantastic. It's all starting up pretty quickly. you'll see all the policies, etc. It says that bin token, etc. here. Now you have to carefully take some of the values present here. You see that the password, etc. is being stored here. This will be coming up only for the very first time. I'm just going to copy it. Once I copy it, I'm just going to paste the thing here. I'll have the password, etc. There are like some strange characters that's not been in it, but the password, etc. is what it matters a lot. Now let me go to my browser. I'm gonna type localhost colon 9200. I need to it runs on HTTPS. It says a connection is not provided, not a problem. It says my password. Password would be like username would be Elastic, and the password should be copied from the notepad. And this is the password for the. I need to copy here and paste it. Once you do it, your Elasticsearch gives a indication it's running up and running. Says that what is my machine name, cluster name, UID, and if you notice your server name, it says 9204. So this is a simple way to figure out whether Elasticsearch is running in the given machine or a node or not. So this will give you the complete information. This is like more of health check endpoint. This gives you the whether it's up or not, any issues, all the details will be coming up over here. Still, Kibana has been extracted. But any questions? Running Elasticsearch as a local node in your laptop, either Windows or Linux, right, is super easy. You just have to download the package and you have to go to the location and open the command line and just say bin/Elasticsearch. That will be helping out.